Screen is visible to all?
Yes, sir.
Okay, okay. So this is visible, like question. Anyone reply? This is the first question I have taken.
Yes, sir.
So it is
It's
asked
visible.
in GATE 2023. So one second. So here a rectifier circuit is given. In this, it is given that the thyristor T1 and T3 are fired at angle alpha is equal to 60 degree, and T2 is fired at angle alpha is equal to 240 degree. So it is asked that what will be the average output voltage across this load. One second, one second. Okay. So here input is sinusoidal waveform. So when T1, T2 will be fired, so what will be the output voltage? In this case, output voltage will be same as source voltage. So here this T1 will conduct and T3 will conduct. So it will follow this path. So here to here. So this point and this point, what will be the voltage? It will be Vs. And when this D1 and T2 will conduct, in that case, what will be the output voltage? In that case, the output voltage will be minus of Vs. Okay. So here I have drawn the waveform. We are firing the T1 and T2 at angle alpha. So in this case, what will be the output voltage? It will same source voltage will replicate at output. At angle pi, what is happening? So this sine wave is becoming negative. So it means here what will be the value? Here value will be like this is plus and this is minus. So here initially it is negative, but what will be value? Here it will be positive and this diode D1 become forward bias. So at alpha is equal that at angle pi, what will happen? This D1 become forward bias and this D1 and T2 will do the free wheeling. So this 10 ampere current will flow through this one. That's why here output voltage is 0. Again at pi plus alpha, what we are doing? We are firing the thyristor T2. So in this case, T2 and D1 will conduct, and T2 and D1 will conduct means in that case what will happen? Output voltage will be negative of the source voltage, minus Vs. So here what is the voltage? Here it is negative. Negative means it will be invert. So again it will go from here to here. Again at 2 pi plus alpha, what will be the waveform? This T1 and T2 again it will be fired. So this sequence will be repetitive sequence. So here we can observe that at initial no waveform is there here to here. But in steady state waveform will be like this. Since before alpha we are not giving the firing angle, but in steady state what waveform we will consider? This waveform will be considered in the steady state. So from this output waveform we can see that what is the time period? Time period from here to here. The time period is the 2 pi. Up to now anyone have doubt in this waveform? How output waveform is coming? Anyone can unmute and ask. Hello?
Clear, sir.
Clear? Okay. Okay. So with this waveform, we can calculate the average value. Average value, how we can calculate? VO average is equal to time period is 2 pi. So 1 upon 2 pi. From here to here, we are integrating. So alpha to pi, first we will alpha to pi. What is the waveform? Vm sine.
Sir, please
Okay. You
once
can ask.
again repeat that
Okay. Okay. Which part?
waveform part.
Okay. Okay. Waveform. So see, at alpha, we are firing the T1 and T2. Okay. So when T1 and T2 will be fired, what will be the value? This point will be, one second. This point will be connected to here. This okay. This point will be connected to this point, and this point will be connected to this point. So at here, what will be the voltage? Same. The source voltage will come at output. Okay. At when this is conducting up to pi, what is happening? At pi here, voltage will become positive. Okay. Since here polarity is here positive and here negative, means when it will come negative here at diode D1, what will be the polarity here? It will become positive. Okay. So when this will become positive after pi, this diode will become forward bias, and we are firing again T1 and T2 when and T2 when we are firing at pi plus alpha. So pi plus, before pi plus alpha, what will happen? This D1 and T3, this is T3, this D1 and T3 will do the freewheeling. Okay, one second. D1 and T3 will do the freewheeling up from pi to pi plus alpha. Again, pi plus alpha, what we are doing? We are firing the T2. So D1 was already conducting, so it will conduct through this path. D1 will conduct and T2 also will conduct. So when D1 and T2 will conduct, what will be the output voltage? Here this is negative and this is positive. So this negative point is connected here and positive point is connected here. So in that case, what will be the output voltage? It will be the negative of the source voltage. Okay. So when T1, T3 is conducting, output voltage is same as source voltage. When T1 and T3 is doing the freewheeling, in that case output voltage is 0. And in this case, when T2 and D1 will conduct, the output voltage will be negative of the source voltage. Okay. So this is I have drawn here. Before alpha, no pulse is given. So output will be 0 only. At alpha, we are giving the firing pulse. So this same voltage will come here. Alpha to pi plus alpha. This D1 and T3 will conduct. So this is sorted, means output voltage will be 0. And pi plus alpha to 2 pi plus alpha, what will happen? This D1 and T2 will conduct. Again at 2 pi plus alpha, we are firing T1 and T3. So till here, this T2 and D1 will conduct and output voltage will be negative of the source voltage. So here, same like you can see here, this is the source voltage. So just I have taken negative of this voltage up to from here to here. This is pi plus alpha. This is 2 pi plus alpha. So negative if you will take, this will come at positive and this part from here, top from here, it will come as negative. You got it? Hello?
Yes, sir.
Okay, okay. So now for average, what we can do? We can integrate one time 1 by 2 pi. What is the average value? 1 by t, 0 to t, something ft into dt. This is the formula of the average of any signal. So this is the output voltage signal. One period is 2 pi. So we can integrate like that 1 by 2 pi alpha 2 pi Vm sin omega t plus pi plus alpha to 2 pi plus alpha. Since here 0 voltage is there, no need to integrate. This will be 0. So alpha to pi first we will do the area under curve. Again pi plus alpha to 2 pi plus alpha. This is one period. So here what will the value? Minus Vm sin omega t, d omega t. Here also it will be d omega t. So here I have written minus pi because here the output voltage is negative of the source voltage. So source voltage is what? Vm sin omega t. So negative what will be? Minus Vm sin omega t. Again we can simplify this one. So it will be 1 upon 2 pi. What it will be? Vm upon 2 pi we can write. Vm upon 2 pi. This sin omega t. It will be minus cos omega t alpha to pi plus. This is already negative. So it will be cos omega t. Again it will be pi plus alpha to 2 pi plus alpha. So what is the value here? Cos minus cos pi. What it will be 1. This minus the 1 plus final we can write Vm by 2 pi 1 plus cos alpha, this first term. Minus cos pi will be 1 and minus minus it will be cos alpha. Again here cos 2 pi plus alpha, what it will be the value? Cos alpha. And again minus if we will take, so minus cos pi plus alpha will be cos alpha. So what will be the final value? VO average is equal to Vm upon 2 pi 1 plus cos 3 alpha. Can anyone calculate and tell what will be the final value? Vm is 100. So 100 upon 2 pi. Alpha is 60. So 1 plus cos 3 cos alpha. It will not cos 3 alpha, 3 cos alpha. 3 times cos alpha is there now. 1 plus 3 cos alpha. What will be the final value? Can anyone calculate? So it will be 50 by pi. 1 plus 3 cos 60, 1 by 2. So 1 plus 3 by 2. Can anyone calculate? So it will be 50 into 2.5 divided by 5.
39.788.
How much? 39.7. So, okay, 39.7. So this is the 2 marks question. If you have clear concept, easily you can calculate. Just you have to check the conduction, where to where it is conducting, and you can calculate the value. So next question I am asking on same question. Can anyone calculate what will be the RMS value of the source current? Can one? I am giving you 1 minute of time, 1 or 2 minutes you can take, and you can tell what will be the RMS value of the source current. It's easy only, one line answer.
I naught into 2 root by 3.
I not, you can tell the final value.
6.
Final value how much? 6 you are getting.
Yes, sir.
Anyone can
8.
tell the final answer?
Oh,
What will be the RMS value of the source current? Source current means this one. Source will be supplying some current. So what will be the RMS value of the source current?
8.164.
No, it's not correct.
70.7.
No, it is also not correct. Can anyone?
5.773.
No, 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 not correct. What is the output current? You can relate with this one. Can anyone draw the source current waveform? What will be the source current waveform? After drawing the source current waveform, you will get to know. See, source where it is, when it will conduct, this T1 and T2 will conduct. What will be the source current? Same as, so this source current is IT1 minus T2. IS is equal to what? IS we can write here. If you this node, if you write the KCL equation, what will be the value? IT1 minus IT2. Okay, so this will be the source current. In 360 duration, only for alpha duration, source current will not present. Okay. See, this freewheeling is happening in all 360. This is the 360 duration, 360 degree. For freewheeling happening for how many angle? Alpha angle only. So when this will conduct, that time only source current will not be present. Other time source current will be present. Either it will be plus 10 or minus 10. Okay. So RMS value shortcut formula how we can calculate? IRMS. IS RMS will be, so conduction conduction angle how we can calculate? 360 minus 60 divided by 360 into 10. So this will be the RMS value of the source current. It will be approximately 9.12 ampere. Is it clear?
Clear, sir.
You can draw the waveform. So for this question, I have done the simulation also. I will show you that waveform. 1 second. So this screen is visible.
Yes, sir. Visible, sir.
Okay, so here I have done the simulation for the same question. I will simulate it and show you the waveform. See, so here we are giving at firing angle alpha. Okay, so before this no current will be there. After one cycle we will see. So here it is one cycle. Okay, so after here we can see the steady state waveform. This source current waveform you can see here below. How it is coming. This is the source current waveform. So in one cycle from here we can observe. This is the one cycle. So here we can observe from here to here. Here to here only for this 60-degree duration, source current will not be there. They are 0. Okay. So for how many angle it is conducting? 300 degree. For total 300-degree duration, source current will be there. Okay. 1 second. Okay. So here the source current waveform we can observe that it is from 2 pi I'm observing. Okay. So 2 pi, this is the source current. Here it is minus 10. Here to here it is minus 10. Again it is plus 10. Again it is 0. Here to here it is minus 10. So for whole 360 duration, if we are observing the source current, it is 0 only for duration of 60 degree. So the formula is the duration for each current will, you can try the RMS value with that basic formula also. That what is the basic formula? Can anyone tell for RMS calculation? Any function, what will be the basic formula for RMS current calculation? If RMS.
Sir, 1 over time period integration or time period or square of the signal.
Okay, this will be the formula. With this also you can calculate. Okay, so source current waveform will be like this one. This something it is going somewhere, it is 0 for 60 degree duration. Again it is, I think, coming minus 1 second. So 0 for some duration, again it is minus. Okay, so this waveform you can consider. So this is 2 pi. Let's say this is 0. This is how much? Pi by 3. So this duration will be 60 degree. Pi by 3. Total you can calculate with this formula also and this formula also. You can see, like, directly you can calculate. The formula is total period for his current will be available. So total period for 360 minus 60 for 300 degree current will be available either in form of plus or minus. But since here we are doing the square, it will be same only. So shortcut formula is you can directly subtract the 0 part. So 360 minus 60 divided by 360 under root into 10. And you can verify the final answer. So final answer will be 9.12 ampere. Is it clear?
Yes, sir. Yes.
Okay. Okay. Anyone have other doubt in this question, like waveform and all? Otherwise, we will move to the next question. Okay. Okay, so I'm moving to the next question. Next question is very easy question. How many of you have gone through the DC to DC converter? Okay. So that is very basic DC to DC converter question. Like you can try it. This is the second question. It is one marks question, get 2023 only. So here for switch S1 and S2, two pulse signal are given. Okay. Switch S1, this is the pulse to switch S1 and this is the pulse to switch S2. So it is asking that what will be the average voltage across this 5 ampere source. You can try first, after that I will explain. Is it visible?
Yes, yes, sir.
Okay, so here we have to calculate the average value of the voltage across this 5 ampere current source. I'm waiting. Anyone can solve, they can reply.
Sir, 6 volts.
6 volts correct only. How many of you are getting 6? Why not 12? How many? Anyone getting 12 also? All of you got 600? Hello? Everyone got the 6 volt answer? Final answer? Should I explain? Can anyone reply?
What?
Okay. Audible? Okay.
Yes, you are audible, sir. You are
Okay,
audible.
okay. So this is very simple question. Just no need to calculation also. So this extra information they have given, this is not required at all. Okay. See, if we are applying switches to pulses to this switch also, since this current is following in this direction, so this will not go in this direction through this switch. Okay. So first case, what is switch one is turned on, so this will source will supply the current like this through this and through this. In second case, when this switch will be off, this current needs a path. So since this switch will off, this will not conduct and this diode also will not conduct. So what will this will do? This will do a freewheeling through this D2. So first case, this is the path. Path will be like this. And second case, when this will on or off, it doesn't matter. Second case, this current will flow like this. So when this switch 1 will be on, what will be the output voltage? It will be 20 volt. So 20 volt for how much duration? 3 microsecond. Microsecond only. Okay, any unit 3 and total unit is 10. Okay. So what is the duty ratio for this waveform? 3 divided by 10 is equal to 0.3. When we will multiply with 20, so what will be the average value of voltage? 20 into 0.3 will be 6 volt. So this is a type of question you no need to use pen also, directly by seeing the, and you can calculate and tick the answer. Just in 10 seconds you can answer this question. It's very easy. Is it clear to all? Can anyone reply?
Yes, sir.
Okay, okay. Okay, so I'm moving to the next question. Okay. This is good question, 2 marks question. So I will explain step by step. So in this question, a power electronic circuit is given and it is asked that the duration in microsecond for which the thyristor will conduct before it turns off. So in before state, what is the condition? This capacitor is fully charged. The circuit shown figure is reached to a steady state at T off. When this thyristor is off, it is steady state. Means this will be short circuit and voltage across this capacitor, what will be the value? This V value. Can anyone tell in a steady state what will be the value of this capacitor voltage? V. What will be the value in a steady state? Can anyone reply? Okay.
0.
No. See, this steady state circuit will be like this. This voltage will be 100. Okay. This switch is off only. This capacitor will be open circuit. This inductor will be short circuit. And here this 4 ohm resistance is there.
Sir, 100 volt.
So here plus and here minus, current is 0. So this 100 volt will come here. Okay. So T is equal to 0 minus, what will be the condition? This will be the condition.
100 volts, sir.
Here 100 volt. So VC minus, VC 0 minus, what will be the value? 100 volt. Okay. And now I'm going to explain further. So this circuit we will take. First I'm taking this circuit. So when this switch will be on, what will be the circuit? So this is short circuit. This switch is short circuit. Okay. So this negative, this initial voltage we can take like VC0 minus S. So it will be VC of 0 minus divided by S. I'm taking in Laplace domain. What will be this capacitor value? We can write as 1 upon Cs, and this inductor value will be Ls. This will be Ls. So when this switch will be on, means this 2 point will be connected. So this 2 point will be connected. What will be the value of current in this direction? This I am taking as IS. Okay. So IS we can calculate as IS is equal to Vc0 minus divided by S divided by 1 by Cs plus Ls. So this we can write as C into Vc0 minus divided by LCS square plus 1. Is it correct? Can anyone verify? Okay. So again we can write this as LC I am taking as common. So what will be value? Vc0 minus divided by LC, at above it will be C into 1 upon S square plus 1 by under root LC whole square. So this CC will be cancelled. Okay. So Vc0 minus into 1 by L here. So a square divided by 1 plus a square, I want to take in that format. So here it is L. So we can write root LC into 1 by root LC divided by S square plus 1 by root under root LC whole square. Up to now, anyone have doubt in this expression, final expression? Anyone can unmute and ask how I have written this?
No doubt, sir.
Okay. So finally, what it will be value? This LCLC will, so it will be, final will be Vc0 minus into under root C by L, and this will be 1 upon root LC divided by S square plus 1 upon root LC whole square. So what will be the inverse transform of this one? So I of t we can write as I of t is equal to this is Vc0 minus, so Vc0 minus into under root here C by L sine omega naught t. So what is the omega naught value? Omega naught is equal to under root 1 by under root LC. Okay. So this will be the current through this circuit when this switch is turned on. Okay. So again, I want to calculate this capacitor voltage. What will be the value of this capacitor voltage as function of time? So Vc of t we can write as Ic is equal to C dV by dt. So Vc we can write as Vc of t is equal to, one second. Ic is equal to C dV by dt. So Vc is equal to 1 by C integral Ic dt plus K. What is the value of K here? K is the initial condition. So in diagram we can see that since IC is going in this direction, so this formula will be valid only when this IC will be input to the capacitor. IC is equal to C dV by dt is the formula when we will use when this IC is input to the capacitor. Since here we are taking an output current, so we can write this equation as 1 by C minus IC dt plus K. Is it okay? Is it clear to all?
Okay, sir.
Okay. So I'm writing this equation again. So I see what we can write this. Let's say this is peak value. Peak value is Vc0 minus into under root C by L. This is I am taking as I peak. Okay. This is peak. So 1 by C minus I peak into sine omega t d omega t plus K. Okay. This is the value of Vc of t. So can anyone calculate what will be the value of K here? Can anyone calculate? K value initial condition, can anyone calculate? Okay, yes, K will be 0. Correct. So this we can write at VC of t is equal to this integral, what will be? So this is 1 by C I peak, we can write into under root uh, C by L VC 0 minus into, so this minus will be cos omega naught t into what it will be, under into 1 by under root LC, so it will be LC. So LC, what it will be cancel. See here, C will be C and L will be cancel. So it will be, final expression will be VC of t is equal to VC 0 minus cos omega t plus K. Okay. So since t is equal to 0 minus, what is the VCT value? 100. So 100 minus 100, what will be the value of the K? 0. So final VC of t we can write as VC of t, we can write as VC 0 minus cos omega t. Okay. So now we will come to the question. See here. One second. One second. Okay. So ICFT we have calculated. This is ICFT. ICFT is equal to I peak sin omega naught t. VCFT is equal to V0 minus VC0 minus cos omega naught t. Okay. So see what will happen when this switch will be turned on. This was in a chart like here. So this is cos omega naught t. So how the waveform will be? Waveform will be like this. This is positive VC 0 minus. So it will go like this. Okay. So after one charging and discharging, what will be this value? Minus VC. It will reverse its polarity. Okay. After one cycle, what will be the value? It will reverse its polarity. So VC2 minus VC. Okay. So when it will become minus VC, so till now we can calculate the value of the T. How much the value? Can anyone calculate till now? This is pi. So we can, okay, omega naught Tc is equal to pi. So what will be the value of T from here? Can anyone calculate? Am I audible? See, omega naught value already you have calculated. This is under root LC into T is equal to pi. So T will be pi under root LC. So this is the first term, like switch is conducting, but and this is also changing its polarity. So what is the final question? What the duration in microsecond for which the thyristor will conduct? Okay. So now also thyristor will conduct, but when this will reverse, what it will do? It will supply current in reverse direction. Okay.
Time 6.283 microseconds.
How much final answer you have calculated?
6.283 into 10 power minus 6.
No, final answer will be 7.33 microsecond. Okay, final answer. Total conduction time. See, I am explaining step by step. Initially, capacitor was charged like this one. Okay, previous condition. When this is turned on, what sequence will happen? This will flow the current in this direction, and it will charge in other, like so VC of t, VC0 minus cos omega t. So at pi, what will be the value? At 0 it is VC, at pi it will be minus VC. What will the current? Current will be 0. Okay. At this point, this is I peak. So at pi, what will be the current? This current will be 0 and this value will reverse. So this polarity at this capacitor voltage will reverse. And after that, what it will do? It will force the current in the reverse direction. So when this load current, this is the load current, and this is the current supplied by this commutation circuit. When this both will equal, this thyristor will conduct till that time. Okay. So first time is this one, pi under root LC. Now also thyristor is conducting only. When this current will reach to this thyristor current, that time it will turn off. So it is asking total conduction time. So switch on means this will reverse its direction. After reversing its direction, again it will start conducting in reverse direction. So when this current will be equal to the load current, that time will be the total turn on duration of the thyristor. So how we can calculate this? Again this peak will be same. So I peak will be Vc0 under root C by L into sine omega naught t. Okay, this is the current for this one. What is the load current? Can anyone tell? 100 by 4. So through this thyristor, like this current will be due to load current. What will be the 100 by 4? How much will be the current? 25. Okay. So when this current will be 25, this current will be 25. That time it will be turned off. Okay. So 25 we can equate with 25 is equal to V0 minus under root C by L. So this will be how much? Can anyone calculate this one? Vc0 minus under root C, it is 100 into under root C by L, how much? 1 by 4?
0.5.
Sine omega naught t. So this is 1 by 2. Okay. So sine omega naught t, how much? How much?
0.5.
Means 1 by 2. So omega naught t is equal to what we can write? Pi by 6 we can write. Okay. This omega naught t will be pi by 6. So what will be the t value? T will be omega naught is equal to 1 by under root LC. So t will be under root LC into pi by 6. So first time is pi under root LC. So here two things are happening. First is T1 pi under root LC, T2 is LC into pi by 6. So first sequence is this capacitor is reversing its direction. That will take this much time. Okay. After it will reverse its direction, it will supply in this direction. So when this current will be equal to this thyristor current, then it will be turned off. So total turn on time will be this T2 plus T1. Can anyone calculate what will be the final value? Final will be T will be under root LC into pi plus pi by 6. This will come as 7.33 microsecond. Anyone have doubt in this explanation? Again, I will repeat. Anyone can ask? Hello?
Sir, please repeat the second operation, sir. The
Okay.
second cycle.
Okay. So see, first this circuit is there. No? This is the thyristor and this is the capacitor and this is like this one. So this battery here is connected with 4 ohm. So what will be the load current due to this resistance? 100 by 4. It will be one current will be in this direction. That is 25 ampere. Okay. And this is reverse charge. After one cycle, what will happen? This capacitor will be charged in reverse direction. So that will be here. It will be like 100 volt in this direction. So this will supply the current in this direction. This derivation I have already done. What will be the value of this current in this type of circuit? So this will be I supplied by the capacitor. Okay. So this is the equation for that capacitor current IC. Vc0 minus into under root C by L into sin omega t. This is so when this current will be equal to this 25 ampere current, then only it will be this current will be 0 and this thyristor will be turned off. Okay. So what am I doing? I am equating this current with 25 ampere. So 25 is equal to Vs under root C by 100 into under root 1 by 4 sin omega naught t. So from here we are getting the time value omega naught t is equal to pi by 6 and omega naught is equal to 1 by under root LC. So this T2 will be under root LC into pi by 6. Is it clear?
Yes, sir. Clear, sir. Now, okay.
Okay. So this T1 plus T2 will be total. So when we are turning on this thyristor, first this sequence will happen. So this sequence will take the time pi under root LC, and second sequence, how much time it will take? Second sequence will take this time. So after T1 plus T2, thyristor will be turned on. So total time will be 7.33 microsecond. Clear? Okay.
Clear.
Anyone have doubt?
No, sir.
Okay, okay. So I'm moving to the next question. That is 2 marks network analysis question, but that is it will look tough, but it is easy only. You can see how I will relate this question. Just 1 or 2 minutes you can solve this type of question. Okay. So I'm moving to the next question. See, this question also asked in 2023 GATE Electrical Engineering. This is a combination of two part. Like in one part, DC part is there and AC part also they are combining. Okay. So how will be the thought process if you will see this type of question? Like see, what they are telling at t is equal to 0 minus, t is equal to 0 minus, this switch is open and this switch is closed. And they are asking the minimum value of t1 in milliseconds such that these switches are turned on, and this is like connecting at t is equal to t1, and this is opening. So this is closing and this is opening at t is equal to t1. So they are asking that what will be the value of T1 such that there will be no transient voltage across this capacitor. Okay. So how the thought process will be in this type of question? So T is equal to T1, this circuit is happening. So what will be the circuit? This will close. This will capacitor will be closed. This is the capacitor and this is opening. So here it will be R and one 5 volt voltage here. This is C. This is 5 volt and this is 10 ohm. So this is just a DC circuit. It is independent from this side of circuit. So they are asking that after t is equal to t1, there should be no transient in this capacitor voltage. So what is the capacitor voltage? Vc of t is equal to V infinite plus V0 minus V infinite e to the power minus t by tau. So it is asking that this part should be 0. How it can be 0? When this V0 will be equal to V infinity, then only this portion can be 0. Okay. So this initial voltage should be equal to what is the final voltage across capacitor? Can anyone tell? What will be the final voltage across the capacitor, steady state voltage after t tends to infinity?
5 volt.
So it will be 5 volt.
I want.
So t tends to infinity, voltage will be 5 volt. So what should be the at 0? At 0 also voltage should be 5 volt. Then only this will be free from transient. Okay. So we can analyze this circuit. T is equal to 0 minus. What will be the capacitor? Capacitor voltage should be 5 volt. Okay. So I'm drawing the circuit at T is equal to 0 minus. See, this is short and this is open. Okay. So what will be the voltage across this capacitor? We can write in function of, as a function of time we can write. Okay. So see, this below part is connected at same point. So this can be avoided. This is sorted. This is sorted means this point and this point are connected together. Okay, so this we can connect here. So the circuit we can draw as 10 ohm. This is sine 1000 t, and here 100 microfarad. Okay. Can anyone tell the value of XC? XC, omega value is given. So what will be the XC? XC is equal to 1 upon omega C. So this is 10 to the power minus 1, 1 by 10 to the power minus 1. So XC value will be, XC is equal to 1 by 10 to the power minus 1. It will be 10. Okay.
XC 10 ohm.
Uh,
Minus
eh,
J 10 ohm.
So this will be minus J10. Okay. We need the voltage here. Voltage as a function of time. We need.
Hello,
Yes, audible? Hello.
sir. Hello,
Yes, you can ask.
sir. When was this K switch was open,
Okay.
then why we not include this IT equal to 700 as in this previous
Previous
case?
one, previous only case I'm analyzing. Previous case only I'm analyzing. I analyzed here the how the thought process will be. We have to reach here. Okay. We have to. They are asking like this case should be free from transient. So for this zero voltage V0 at t is equal to T1, they are asking the time at which time this should be closed such that this DC part will be free from transient. Okay. So see, if this is turning on means this DC part will be separate. This part will be connected means AC part will be this side and DC part will be this side. Is it clear? If this is closing means this point and this point will be sorted together. So this we can sort here. Like this DC part will be separate and AC part will be separate. Is it clear?
Okay, sir. And okay, sir.
See, after T is equal to T1, what they are doing, they are sorting this source. Sorting means this point will be connected here. Okay. So this will be a separate circuit and this should be free from transient. So as T is equal to T1, when this event is happening, this voltage across this capacitor should be 5 volt. 5 volt. So what I'm doing here, I'm trying to write this voltage as a function of time. So we can equate that with 5 volt, then we can calculate the time. What should be the time when this voltage will be 5 volt? Is it clear?
Yes, sir. Sir, when this K switch is sorted, then this current will not flow in this circuit.
No, it will be independent. See, this point I'm connecting here. Okay, same potential. So this will not contribute anything here in this side. Are you
Okay.
getting? Same potential means
Yes.
it is sorted. Sorted means we will connect it here. Are you getting?
Means
This side,
means
this
it is
this
directly connected to
if
ground.
no, if it will contribute some current also, that will be through this sorted branch only. This side of branch it will contribute nothing. Capacitor. Are you getting? See,
Okay. Yes, sir. Yes, sir. I got it.
sorting 2 points means this we can like place at same point here only. Okay, like this in first case, these 2 points are sorted from AC circuit. So in first case, what am I doing? I am excluding this circuit because this point and this point are at same potential. So this we can connect like this 10 ohm, this 5 volt source, and this is connected here. So this is like what is the current division rule? If 2 points, 2 impedance will be connected, there we can apply the current division rule. So this 2 point is there. This 10 ohm is this side and 100 microfarad is this side. So we have to calculate this voltage across this capacitor. Is it clear?
Yes. Thank you.
See, if any point will be sorted now, that part of circuit we can exclude. Okay.
Yeah. Okay, sir. Yes, sir.
Okay. So now I am going to calculate this VC of T. So we can apply the current division here. So what will be the value? Minus J. This is 10 divided by 10 minus J10 into directly I am calculating the voltage into what will be the value minus J10. Is it clear? This will be the final value. Current division means opposite side. Opposite side divided by this summation 10 minus J10 into this value minus J10 into this function will be multiplied here. So first we will take what will be the value. This 10 will be cancelled. So it will be minus J by 1 minus J into 10. Okay. So for this complex number, what will be the magnitude and angle? Can anyone tell? This is the complex number which will be multiplied with sine. So any sinusoidal, if we are multiplying with complex number, it will contribute one angle and one magnitude. So can anyone tell what will be the magnitude of this complex number? Anyone can reply?
Just a minute, sir.
Okay.
Sir, can you please
5, sir.
Should I
explain
repeat?
from beginning, sir?
Okay.
Sir,
Okay.
magnitude 5.
Sir,
Okay.
just to
Okay.
explain it.
Okay. I will explain. See, T is equal to 0 minus, okay? This is open and this is short, okay? So this is open, this is short means what I am doing, I am trying to write this capacitor voltage in terms of time at T is equal to 0 minus, okay?
Okay, sir.
So T is equal to 0 minus, this circuit will be there.
Yes, sir.
This part is sorted means this I connected here. This is the
Okay, sir. Yes, yes, sir.
okay.
Got it, that one.
So this J by 1 minus J into 10. Okay. And this is a circuit as T is equal to 0 plus. Okay. So T is
Wait,
equal
sir. Let me see once. T is equal to 0 plus. That K will be.
see this
K
will be
switched on.
sorted. This is
will be
K
sorted,
here.
okay.
K is sorted. And this point will be connected here. This point, this top point will be connected here. This will be this. So I am sorting here. Like see, like this will be here. Like
Okay, sir.
this one, this will be her one source, and this will be connected like this one. So this so what they are asking, this should be free from transient. So T is equal to 0 minus some voltage is required. That voltage should be 5 volt. So at what
So in
time?
T is equal to 0 plus, this AC will not affect that capacitor.
No. See, this is sorted means it will follow this path only.
Okay.
Always it will follow low resistance path. Sorted means it will not come here.
No. Yes, sir. Okay.
Is it clear?
Okay.
Okay. Now I'm calculating. So see, this will be the, what will be the magnitude? 1 by this root 2. So magnitude will be 10 by root 2. Is it okay? For this complex number? Total 10 by root 2. Under root A square plus
7.07.
final answer you are telling? Okay. Like that you have calculated. 10 by root 2, 7.0. Okay. What will be the angle? So see, minus J angle will be minus 90. At top, what will be the angle? Minus 90. 1 minus J, what will be the angle? So we will write in coordinates. This is 1. And this
minus
is
45.
So
plus
below
45.
it will be minus 45. At top it will be what it will be? Total angle will be minus 45.
Minus
Total
45.
angle will be how much? Minus 45.
Minus 45.
So we can write the sign value as V of T is equal to 10 by root 2 sine 1000 T minus 45 heart you can write pi by
Yes, sir.
4.
4.
Pi by 4. Okay. So this value should be equal to 5 volt. Then so this is the T. See, asking what is the value of T1. So T1 means initial condition. So at that T1, the capacitor value should be 5 volt. If it is reached at 5 volt, then we are closing the switch means 0 voltage also will be 5 volt and infinity voltage also will be 5 volt. So the transient will be 0. Okay. So this is the VC of T. At what T1 we will close that this switch we will close and this we will open such that this circuit will be free from transient. So at that point this function of this VC of T should be 5 volt. Is it clear? So from this equation we can calculate the value. So what it will be? Sine T minus 5 by 4 is equal to how much? This is 1 by root.
Sir, root 2 by 2.
Sir, final answer 0.
1 by root 2, sir.
1 by root 2. So it will be also like sine inverse 1 by root 2 how much?
45 pi by 4.
So 1000 T is equal to pi by 4 plus pi by 4, 2 pi by 4
Pi by 2.
equal to pi by 2. Okay. So T will be pi by 2000. Can anyone calculate?
3.1.
Is it 1.57 millisecond?
I think, sir. Yes, sir. 1.57 millisecond.
So
Yes, sir.
this is easy only. If you have good clear concept, this is just like for explaining I am taking this much time, but whenever first time I have seen this question, it took me 2 minutes, maximum 2 to 3 minutes to solve. So if your concept will be clear, you can easily solve this type of question. 2023 paper was tough also. Still this is not the tough question. What they have done, they have connected two concepts together. Okay.
Yes, sir.
Now it's almost 8. Anyone have doubt in other question they can ask. So what will be the my upcoming session agenda? So I will come up with some good power electronics question. Most of the question will be from power electronics. So what I have observed during my preparation time, like understanding the three-phase rectifiers and some difficult question from power electronics, people will face challenges. So I will try to make that solving skill simpler, such that you can easily solve any gate power electronics question or any difficult power electronics question also.
Sir, I just have one request, sir, that
Okay.
if you teach the power electronics, so just one class if you give for the theory part, the important formulas that part, then it will be much again like beneficial for
Okay,
us.
okay. See, so what I will do, I will see whole I cannot teach, because
Yes, sir. Just
see what I will do, whatever the concept I have collected, like some shortcut, like for RMS I have some tricks, some formula is there. That
Mhm.
theory also I will take. With question I will explain the waveform also. If I will do any question, so
Mm.
before that question I will explain the waveform also, like how you can analyze the waveform. Three-phase waveform, mostly people are facing the challenges, like which time diode will do the freewheeling. So all the things, like live teaching means I can do the thing well, and I will try to make the thing simpler. Okay.
Okay, sir.
So I
Sir,
will.
sir, can you please explain that VCT final equation
Okay,
once more,
okay.
please?
Which one?
The
BC.
VCT final equation, sir. V infinity plus
Okay, okay.
V0 minus V infinity.
Okay. That is one derivation. We should know that. Like that should be remembered.
No, no, sir. Not about the derivation, sir. Just values.
Okay. See, this is the final equation I have written here. VCT is equal to V infinite plus V0 minus V infinite, e to the power minus t by tau. So this is the equation for this kind of circuit. Let's say this is capacitor. So capacitor one zero voltage will be there and one infinity voltage will be there. RC circuit. This is the equation for RC circuit. Okay. So VC zero minus some voltage will be there, and this is RC circuit, and this is V. So in that case we can write VC of t is equal to V infinite. This is steady state voltage plus V0 minus V infinity into e to the power minus t by tau. This is the equation. This you can derive also by
Sir,
applying.
sir, please. I
Okay.
understand the equation, sir.
What is the doubt?
I just want to put the values in the equation and get to this 10 by root 2 sine 1000
Oh, okay,
minus
okay.
5
See, so
f4, sir.
in question what they have asked now, at what time this should be closed such that this capacitor will be free from transient. So at that time, this capacitor zero voltage should be 5 volt. Okay. So this is the capacitor equation in function of time. So T is equal to T1
Sir,
means
this is at t is equal to t1, sir. This
T1
is at
means
t.
this is initial condition. Like
Yes,
before
sir.
switching, this should be instant. See, this is sinusoidal, some waveform is there. So at some instant we are doing the switching. Okay, this is not a constant waveform. Capacitor waveform is a some sinusoidal waveform or cosine waveform. At some particular time, if we are switching it, it should be reach 5 volt. Okay. So T is equal to T1 means what it meaning? It means initial condition. T is equal to 0, we are opening the switch. Okay. T is equal to T1 opening means at that T1, this capacitor voltage should be 5 volt. Is it clear? Means
Yes, sir.
it should be clear. Like it is asked indirectly. Like at that point, when it will reach 5 volt, it means that should be considered as initial condition, because T is equal to 0 minus capacitor voltage is not constant. It is variable. So at what time it will be switched on, that time voltage will be considered as T is equal to 0 minus voltage. Is it clear?
Yes, sir.
Okay.
Sir, the thing is, we are basically finding out the VCT value,
Okay.
means the generalized equation and equating with 5 volt, right, sir?
Okay.
So the thing is, we have to first find out the value of V infinity. Then we need to find out the value of V0, which we already know that is 5 volt, as we
No.
have supplied it with a DC1. So we just have to put V infinity value plus again we need to write the equation. I just want you to
See. I
write
will,
that
I will,
equation.
I will explain again. See, T is equal to 0 minus this part will be separate. Okay. So T is
Yes.
equal to 0 minus which part will contribute the capacitor voltage? That will be contributed by this AC source. So this is the function, capacitor voltage function T is equal to 0 minus. Okay. So at what time we will switch on this, this will turn on, this will turn off, such that this will have no transient. So at T is equal to T1, we are turning it on and turning it off. So this part will be separated. Okay. So at that time, whatever the voltage will be stored in this capacitor, that will be 0, T is equal to 0 minus voltage. After that, this circuit will come into the picture. Okay. This circuit will come at T is equal to 0 plus, like T is equal to T1, this circuit will come in the picture. So that stored voltage at T is equal to T1, this is one function of time. So at some time we are doing this event. So at that event, this stored voltage should be 5 volt. Okay. So this is one sine wave at T is equal to T1. If this voltage will be 5 volt, so then in this circuit, if this is 5 volt, let's say D is equal to T1, we have done this thing. So what will be the voltage here? 5 volt. As per this equation. As per this equation, what will be the value of the voltage here? 5 volt.
Sir, one thing. At T equals to T1, we are opening the switch K and closing the the switch K is closed and K dash is opened.
Yes,
right,
yes,
sir?
yes.
So basically, we are isolating the AC and DC part, right, sir?
AC and DC part we are isolating.
Yes, sir. Understood, sir.
Now it will be clear, I think. That just you have to calculate this is a variable voltage. Okay, at some point of time it will be 5 volt. That point, if we are isolating the switches, then this circuit will be free from transient. If stored voltage will be 5 volt, if in this circuit, what will be the value? This value only will be there. This will be 0. Is it clear? Okay.
So, sir, initially the voltage which will come is due to the AC source, and after the switching, it will be only due to the DC source.
See, at some point of time, let's say this is the function of time. This is at some time this voltage is variable. If even let's say we have connected a capacitor with
Sir, just sir, you can change that T to T1, sir. Then he will not get confused, sir. If you change that T to T1, sir, he will get the idea that it is that instant, sir. At T is equal to T1, this is
okay.
the value.
Let's say this is the VC of T. Okay. At some time we are, let's say at some time we are doing this. So at that point, capacitor will be charged up to that value. This capacitor we have connected across some AC capacitor. What is the voltage? Some AC voltage. Okay. So it is variable. At any instant, if we are removing the AC source, means that point of voltage will come here. Okay. Is it clear? If we will remove at that peak, this peak value of voltage will come across this AC source, this capacitor. Is it clear?
Yes, sir.
Okay. Okay. Thank you all.
Thank you, sir.
We'll meet
Sir,
on
what is the tomorrow's agenda, sir? Like the same type of question or like?
Mostly I will come up with not a gate question. I will select the question from anywhere. If I will find some good question, so mostly power electronics question I will cover, and network also if I will find some conceptual question, so that I will discuss. So network also, if I am explaining some question, it means we will learn some shortcut method. Like people are solving it like long trick, but I will try to explain with short method by combining the KVL and KCL together. So if you will see that network question also, it will improve your solving skill. Like the question you will solve in less time. Okay. So I will take in like synchron whatever the you will face difficulty in that some most of the I will take some survey. So if more people will be interested in that kind of subject like synchronous machine or some part of power system also, that I will cover. But mostly I will take power electronics and electrical machines.
Sir, you are going to take class tomorrow also, sir?
Not tomorrow. Mine will be, this will be weekly session. Tomorrow another person will come.
Oh, okay.
Like every
Monday.
different people are coming. So my target will be like, it will like I will do such that I will tell some tricks and how to solve the tough question in easy way. Okay. Whatever the experience I have till now, I will try to deliver all the shortcut things to you such that you can score good in. So how many of you have joined the test series, get test series till now?
I have not done it. Not joined.
So I will recommend you all, like all of you should join the test series. Okay.
Which one, sir?
Any test series, like so many are there. Like ACE will be best, I think, or and that question level will be good. Ace Academy,
Mhm.
that will be
Sir,
best.
I have one, sir. I want to ask you one question.
Okay.
Sir, sir, in this 2023 gate, sir,
Okay.
IIT Kanpur, this is a premier institute for electrical questions. So
Okay.
they gave such a hard paper, tough paper. They made such a tough paper for
See,
electrical engineering students.
okay,
Sir, I
wait.
want to ask this IISC. It
No,
is
no, it's
famous for which particular
no,
stream?
no. It will be moderate only, not famous. See, if paper will be tough also, na, they it will be comparative. If you have solved the more number of question, collected more number of concepts, so 50 marks also, like if in 20 this year if you are getting 50 marks also, your rank is under 100. Okay,
Yes, sir.
so no need to think about that. Just you should do your work. Don't
No,
think
sir, I
about.
am not asking that. IISC is famous for which particular stream? Like
Like,
I'm then we will
okay,
have an idea, sir.
no, electrical also they will ask good question only, but question will be just like previous year, like IIT Kharagpur has done. Similar kind of pattern you can see.
Because this time, sir, IIT Kanpur, sir, our mind was just hang, sir, in the.
No, no, no need to think. See, you have to learn. Like after some time, you will get some collection of concept. Okay.
Yes.
No need to
Sir,
think about the exam. You should just do the good like practice question, practice previous year and test series you can do. After
sir,
in test series, you can improve your marks. Like if you are getting full test 50 marks, 60 marks, you can reach up to 70. Then you will get some confidence. Okay.
sir,
Yes,
one
sir.
thing, sir, where can we get comprehensive questions to practice, sir? Is there any source we can practice for each subject?
Books are
Subject.
there, no, for that.
See, I will suggest you go like this since time is less. You only solve the previous year gate question and do one test series. That will be more than enough.
Okay, sir. Thank you, sir.
Okay.
Okay, sir.
So thank you all. We'll meet on the next Monday. Other daily also some sessions are going on. You can join and you can ask your so main benefit of this session is one to one you can ask your doubt.
Yes, sir. Yes, sir.
This is the main benefit. Like live session, some professionals are doing on YouTube also, but they will not take one to one doubt. So here you will get one to one doubt. That will be the
Yes,
benefit
sir.
of this session. Okay.
Sir,
Okay,
one
sir.
more thing, huh? Tomorrow, as per the schedule, there is no class, sir.
Okay. So maybe tomorrow no class will be there. In NPTEL website only you can check their links have been there already. I
Yes, sir.
think.
Yes, sir. Tomorrow, Tuesday, they haven't put any classes. Monday, Wednesday, Thursday, two classes are there. Friday,
Okay.
Saturday is there. Sunday and
So
Tuesday
I
are
will
not.
tell you all of you, you can join those sessions and you can ask your personal doubt also there. If you have some other doubt also, it's not like whatever we are explaining, that only we will explain. Other doubt also you can ask, then things will be more clear. Okay. So you should, all of you should take the benefit of all the sessions and you should join that.
Okay, sir. Thank
Okay.
you, sir.
Thank
Okay,
you
sir.
all.
Thank you, sir.
Thank you.
Thank you
We'll
so
meet
much
on
for
next.
a wonderful
Okay.
session, sir.
Thank you. Okay. Okay.
Thank you, sir. Very good initiative
Thank you, sir.
from NPTEL.
Thank you,
Thank,
sir.
thank you. Okay.